Module 11.3, Brass Instruments. The brass instrument family comprises wind instruments that produce sound when the player buzzes their lips into a mouthpiece that's connected to tubing. The instruments can be made of brass or any other material, silver, steel, fiberglass, and even wood. Instruments of the brass family from small to large include the trumpet, bugle, cornet, flugelhorn, French horn, mellophone, trombone, baritone, euphonium, tuba, sousaphone, and contrabass. All brass instruments have a mouthpiece, tubing, and a flared bell at the end. The source of the sound is a changing airflow caused by the buzzing lips. The filter is the tubing of the instrument, which amplifies the sound at resonant frequencies of the tube. The buzzing lips allow pulses of air to flow. And as we learned in Module 11.1, pulse waves contain all frequencies, so they are a good sound source. So the brass instruments make sound by buzzing lips. So here's how we buzz our lips. All right, and then we buzz those lips into a mouthpiece. Now you notice that as he buzzed his lips, he was able to go make a full range of frequencies from low to high, continuous. So now watch what happens as he does the same continuous buzzing up and down, but with the trumpet on. So we only hear the notes of the harmonic series. Now, we also have something called valves, and this allows us to play the notes in between. So if we don't use valves and just use the horn, you can play some songs. So for members of the brass family, sound is produced by buzzing lips into a mouthpiece. So here we have a mouthpiece attached to a rubber tube and a funnel, and here's the sound that we get. Now it turns out the length of this tubing is the same length as the tubing of a trumpet. So let's hear the difference when we put it on the trumpet tubing. Now it turns out the size of the mouthpiece makes a big difference for the pitch of the instrument. So here is a trombone mouthpiece, which is larger, and listen to the frequencies that we hear now. So you see, with a larger mouthpiece, we get a lower frequency. Brass instruments are essentially tubes closed at one end. The lips make the closed end. Trumpets, French horns, and trombones have cylindrical bores, or tubing. Flugelhorns, baritones, and tubas have conical bores. As you learned in Module 4, the resonant frequency of any harmonic for a tube closed at one end is F equals NV over 4L. A trumpet is mostly a cylindrical tube that is about 140 centimeters long, or about 4.6 feet. So, we would expect the fundamental frequency and resonant harmonics to be odd multiples of the formula, giving us 61 Hz, 184 Hz, 306 Hz, 429 Hz, etc. This would correspond to F1, the fundamental, F3, which is an octave and a fifth above the fundamental, and F5, which is 2 octaves and a third above the fundamental, etc. Adding a flared bell onto the end of the tubing changes the acoustical properties of the instrument. As it turns out, the bell raises the frequencies of the resonant peaks, so the timbre changes. It makes the instrument louder, it makes the instrument easier to play, and it makes the sound more directional. Also, it turns out that the rule about odd harmonics in a tube closed at one end apply only to a cylinder. The flared end and conical bores cause more complex acoustical effects, resulting in all harmonics resonating in brass instruments. The first 16 harmonics are listed here. This is what's known as the harmonic overtone series. So, with a bugle, which is just tubing, you're limited to only the notes of this overtone series. Taps and reveille are songs that are based on this overtone series. In order to play the notes in between the notes of the harmonic series, you need to change the length of the tubing. This is accomplished by adding extra tubing and valves, which close off and open the different sections of tubing. Also, all brass instruments have a section of tubing called a tuning slide. It slides in and out slightly so that instruments can adjust their pitch to a tuning note. This is important because pitch is affected substantially by temperature. Since frequency equals velocity over 4 times the length, and velocity decreases as temperature decreases, frequency decreases as temperature decreases. So, to tune the instrument, brass players change the length of the tubing with the tuning slide. And to play different notes, the players change the tension of their buzzing lips and press valves to change the length of the tubing. The trombone operates differently. Rather than using valves to change the length of the tubing, the player moves the slide as well as changing the tension of their buzzing lips, which gives them a continuous range of pitches. Just like an orchestra string player, they need to learn exactly where to move the slide and develop a good ear to be able to play in tune. Brass players will often use mutes to change the timbre of their instrument. Mutes restrict the airflow near the bell, which reduces certain frequencies and emphasizes others, depending on the design of the mute. Mutes also reduce the volume of the instrument substantially. Pause this module for a moment and listen to the short YouTube video on mutes listed in the info section. Finally, the material the instrument is made of does not have a large effect on the sound of the instrument. More often, the differences are noticeable to the player, but not the listener. Many sousaphones used in marching bands are typically made out of fiberglass. And around 2011, the pBone, a plastic trombone, began to be manufactured and became popular for students and as a spare horn for gigging musicians. Pause this module and listen to the short YouTube video on the pBone versus trombone listed in the info section. To review, brass instruments are wind instruments that produce sound when the player buzzes their lips into a mouthpiece connected to tubing. Brass instruments do not need to be made of brass. The source of sound is changing airflow caused by the buzzing lips. The filter is the tubing of the instrument. Mouthpiece size affects pitch. Brass instruments are tuned by changing the length of the tubing with the tuning slide. Except for the trombone, brass players play different notes by changing the tension of their buzzing lips and pressing valves to change the length of the tubing. Trombone players play different notes by changing the tension of their buzzing lips and moving their slide to change the length of the tubing. Buzzing lips will only excite the resonant frequencies of the tube. Adding a flared bell raises the frequency of the resonance peaks so the timbre changes. makes the instrument louder, makes the instrument easier to play, and makes sound more directional. Mutes change the timbre and reduce the volume of a brass instrument.